Welcome back to my channel Kishore Sir Ki Pathshala. We are doing chapter Carbon and its compound 10 Cbse. So last time we have seen what is saturated and unsaturated compounds. So let's see what are hydrocarbons all about and their general formula. We know that the carbon compounds which contains only carbon and hydrogen are called as hydrocarbon. So last time also we have seen this. Alright. So hydrocarbons are nothing but what? It contains my carbon and hydrogen only. Okay, no other atoms are involved in this. Alright. Okay, so they might be in any numbers as such. So that we need to remember. So what are hydrocarbons? Which contains carbon and hydrogen together. Right, so these are called as hydrocarbon. Okay, now hydrocarbons are divided into what? They are classified into my alkanes, right? Then my alkene and my alkynes, right? Okay, so now what are these alkenes, alkene, alkanes, alkene and alkynes? You'll see that we have already seen the power of catenation, right? So we know that there is a single bond between carbon and carbon. If there is a single bond between carbon and carbon, right? Okay, so these hydrocarbons are called as what? These are called as alkanes. If there is a double bond between carbon, so these are called as alkenes. And if there is a triple bond between carbon, so these are called as alkynes, right? So now what you see is that here you see a single bond is there between carbon. Okay, so this is what? This is a saturated hydrocarbon. This is my saturated hydrocarbon, right? Okay, this is my saturated hydrocarbon. Now you'll see that in both the cases here is a double bond and here is a triple bond. So these are what? So these are my unsaturated hydrocarbon. Both these are what? My unsaturated hydrocarbon, right? So earlier also we have seen that saturated hydrocarbon. What happens in saturated hydrocarbons? Here the reaction tendency is very less, right? Okay, here you will see that the reactions will be at the higher rate. So these reactions we are going to see in our further classes as such. Okay, so here what we need to remember is that we have alkanes, alkene and alkynes, okay, which comes under hydrocarbon. Now let us see the general formula for alkanes. The general formula for alkanes is CnH2n plus 2. Now what this means? CnH2n plus 2. Here the N is the number of carbon. Right. Chalo, let's see. For example, if you want to have as two carbons are there. Here is the case. Let's take this example. Two carbons are there. So we have taken two carbon. Now we want to find out the number of hydrogen in this. So what we need to do? 2 into 2 plus 2. Alright. Okay. So how much it will be? It will be my 4 plus 2. So that is what my is C2H6. Alright. Okay. C2H6. So here you will see carbon is tetravalent 1, 2, 3, 4, 5, 6. I'll just replace this by this hydrogens everywhere and you'll see 6 hydrogens are there. So C2H6. So this formula fits for alkanes. Alright. And so that we need to remember. If you know the formula, what you need to do, just put the number of carbon in that. Okay. So propane, what you will do, you will put C. How much? You will put C3 here, right? C3, and what you will get? 3 2s are 6, then 7 8. So C3H8 you will get in case of propane, right? Okay. So same way for alkenes, The formula is what? CnH2n, right? And for alkynes, the formula is what? CnH2n minus 2. You just need to put the number of carbon here. You will get the number of hydrogen, right? Okay, same way. Just put the number of carbon and you'll get the number of hydrogen accordingly. Okay. So after this, let's see how many friends carbon has got. Now what does this mean, how many friends carbon has got? Now you will tell carbon has got only one friend, that is my hydrogen, right? Because it's hydrocarbon. Okay, it's hydrocarbon. So hydrogen is the best. Yeah, we agree that hydrogen is the best friend of the carbon. But carbon has got many friends as such, right? So carbon has got a bonding with elements such as halogens is there, oxygen is there, nitrogen is there, sulfur is there. Okay, so what we see is there we have got carbon tetrachloride. Here you see halogen. Okay, in this case you will see that. We know that carbon is what? It's tetravalent. Okay, so what happens is that here you see hydrogens will be there. So one of the hydrogen will be replaced by any of this. Okay, any of the element as such. And then it becomes like this. Here you see 8, here Cl. Okay, so now more 3 hydrogens are there that can also be replaced. Okay, so in hydrocarbon chain, one or more hydrogen can be replaced by these elements. Okay, such that the valency of carbon remains satisfied. You need to know that at any given point, the tetravalency of the carbon has to be satisfied. Right? You cannot put here 2 Cl. Tetravalency will become 5. No, that's wrong. So the tetravalency has to be satisfied at any given point. So in such a compound, the elements replacing hydrogen is referred as heteroatom. So this is known as what? This is my heteroatom, right? So that we need to remember. Okay, so these heteroatoms and the group containing this impart specific property to the compound. Okay, regardless of the length and the nature of carbon chain, and therefore these are called as the functional group. Okay, so look, let me give you an example. Okay, in this case, the first you will see that CH-4. This is what? This is my methane, right? Okay, this is my methane. Now you will see that if I replace one hydrogen with chlorine, okay, one hydrogen I have replaced with chlorine. So what will happen? One hydrogen goes. So it becomes CH3 and Cl will be there. Okay. So this is my chloromethane. Right. Now you will see that the properties of methane and chloromethane are completely different. Right. Why? Because the functional group is been attached. Right. What is the functional group? Is my halogen. That is my chlorine. Okay. So that comes under halogen, chlorine, bromine, fluorine, iodine. Right. So a functional group is attached, and because of the functional group, what happens? A specific property is imparted to the compound. Right. Regardless of the length. Now what it means regardless of length? This is my chloromethane. If there is this thing CH3, CH2 and Cl, this is what my chloroethane, right? So methane and ethane, chloroethane. What has happened? The length has increased. Okay, right? But what will happen is that the properties of these remains the same, that we are going to see in the next topic, that is homologous series as such, right? So you have understood till the functional group. Okay, these are nothing but these are the heteroatoms, okay, which are attached, right, to the carbon, hydrocarbon as such, by replacing the hydrogen, and it imparts a specific property to the compound regardless of the length of the carbon chain, and therefore they are called as functional group. So there are some functional groups here. Let us try to understand. Okay, let's see this. I told you that is my halogens, that is the halo group. Okay, so here you see chlorine, bromine, right? So formula of the functional group is what? See here. Okay, so free valency or valency of the groups are shown by a single line. Okay, the functional group is attached to the carbon chain through their valency by replacing one hydrogen atom. So now we are given you an example. What happened is that here you see hydrogens are there. Okay, 4 hydrogen tetravalency, then the hydrogen is replaced, right? And it becomes what? CH3Cl in this case. Okay, so there are many other functional group as such. Let us take alcohol, right? So see here, CH3, one hydrogen replaced, right? One hydrogen replaced by this OH group, hydroxyl group, one hydrogen is replaced. So this becomes my alcohol, right? The functional group here you see is alcohol, is a functional group. Then we have got this aldehyde. We have this aldehyde here. Here is my aldehyde, right? So here is the what shown as a single line, okay? And this attaches to the hydrocarbon as such, right? Then I have got ketone. So ketone, you'll see that ketone is like this. Okay. So ketone attaches to what? Two other hydrocarbons. Then this is my carboxylic acid. This is my carboxylic acid. Here you see a single dash is there. So it attaches to the hydrocarbon like that way. Okay. Where the hydrogen is replaced. Right. So this is what we have learned today about the functional group, how these functional groups are important, right? So that's how you make the, here you see you have got alcohol, okay? Then you will get aldehyde also. Now we are going to see how to name all these compounds as such, right? So I'm sure you have understood today's topic, that is how to differentiate between alkanes and alkynes, what are their general formula as such, how to write down the general formula. If you know the number of carbons, you can write down, you can know the number of hydrogen accordingly, and also what are the heteroatoms, what are the how they are called as the functional groups as such. So student, keep watching my channel Kishore Sir Ki Pathshala, and you like, share and subscribe Kishore Sir Ki Pathshala.